Hi, everybody. It's Mr. Geiselman here to talk to you a little bit about our new unit. Today, we're going to start with electricity and static electricity as we start our electricity unit. Here we go. So, electricity is simply energy caused by the flow of electrons through a material. Now, most of the time, that material is a wire or some sort of electrical device, but anything that has electrons moving through it technically is conducting electricity. So, that electricity is anytime that electrons are flowing through a material. When we look at electrical charge, you guys probably already know this, but there's two types. We can have a positive charge or a negative charge. So a positively charged object is going to have more protons than electrons. So it's going to have a higher positive charge count. And electric charge with a negatively charged object is going to have more electrons in it. So the picture below shows three different charges. One is a neutral, one is a positive, one is a negative. The one with more positive charge, more red protons than electrons, is going to be the positively charged object. The one with the same amount of electrons as protons is going to be the neutral object, where it doesn't have a positive or a negative charge. And the one with more blue electrons is going to be the negative charge. You've probably heard this before, but charges interact in an interesting way. So opposite charges attract. A positively charged object or a positively charged subatomic particle like a proton is going to be attracted to a negatively charged electron. So things that are positive are going to attract things that are negative. And then the opposite is true, that like charges actually do push against each other. They repel. So there's a force between them that pushes them away. So a negative charge will push away another negative charge, and a positive charge will push away another positive charge. When we look at subatomic particles, just a little bit of a review, that the electron is that negatively charged subatomic particle with almost no mass. We abbreviate that with a lowercase e, all right, and it always has that negative sign by it. The electrons are outside of the nucleus, all right, and they orbit around the atom. The proton then is inside the atom. It's the positively charged subatomic particle. It's found in the nucleus with the neutrons. We abbreviate that with a lowercase p with a positive sign next to it, right? And it is within that nucleus, so the electrons orbit around the positive protons. Electrons are really easy to get rid of, and that's why the flow of those electrons constitutes electricity. So, an insulator is a material that does not allow for electrons to freely move through it. You can think of a lot of things like rubbers and plastics. If you have a set of headphones that are wired, there's a wire inside of there that conducts electricity. Well, there's a rubber coating around it. Those insulators like to hold on to their electrons and they don't give them up very easily. So anything that's not going to allow their electrons to move is going to be an insulator, right? Rubber, glass, and other plastics are really good insulators. They don't like to let the electrons move through them. Conductors, on the other hand, are the things that do let the electrons move freely. They let them go in and out, and electrons can move fairly quickly through conductors. Coppers and most metals are conductors. There's few other things that work as conductors, and conductors really like to let those electrons flow. If you want to think about it, they hold on loosely to them. So things like wires are conductors; they let those electrons flow. But there's other things that are conductors that we might not think about. A banana is full of the element potassium, and potassium allows electrons to move quickly. It is a metal, and they're called electrolytes. You might have heard of those before if you've ever had a Gatorade. So that actually allows you to move, or those electrons to move quickly, and that serves a purpose in your body, especially when it comes to moving muscles and contracting and releasing those contractions and relaxing those muscles. So take a second, go through the items on the screen. Is a nail conductor and insulator? Are tires conductors or insulators? Is a potato a conductor or an insulator? And is a human a conductor or an insulator? So there's another piece of electricity that we're going to talk about today. All right. So we're going to watch a quick video, and hopefully all of you are getting close to getting your driver's license. You're 14, 15 years old. All right. And you'll have to start pumping your gas. This week, it's been extremely cold. So a lot of people like to pump their gas inside their cars. So this woman is about to start pumping her gas, and she makes kind of a cardinal sin of pumping gas. So she starts the pump here, and she decides that once it's going, that she is going to sit back in her car. Now, what could happen, right? So we'll speed up until she comes back out of her car and goes back to the pump. So it's been pumping this whole time, and she's been sitting in her car. Now it's time to take the car out, or the pump out, and look what happens. Pretty good result for what happened there. So the gas actually started on fire. What caused that fire? Well, there was some static discharge. So there was a buildup of electrons on the woman, and when she touched the conductor, the handle of the gas pump, it sent a flow of electrons, some electricity, static electricity. Sorry about that. So when she went back to her car, somehow she built up a charge, a negative charge, an excess of electrons on her body. And when she touched a conductor, well, they jumped from her body to that conductor, creating a spark. We'll take a look at how that actually happens. So how does an object become charged through friction? This is how static electricity often occurs. An object rubs up against each other. You can think of your hands rubbing up against each other. That's a good example. Now, some, again, objects like to hold on to their electrons really tightly, and some are really good at letting them go. So the object that loses the electrons, all right, is going to become positively charged, all right, and the other object is going to gain those electrons and become negatively charged. If we have a big enough buildup of electric charge, or negative, specifically negative electric charge, or lots of electrons onto that object, then we can actually have that static electricity discharge. It's called static electricity because it's not moving through your body all the time, or through whatever that object is. It's kind of stuck there, and that's what static means. We'll take a look at that. So here we have John Travolta. This is a PhET simulation. Now his foot is the conductor in this case. It's going to pick up electrons from the carpet. So he builds up those electrons onto his body. Through friction, he's rubbing the electrons off the carpet onto his body. What they do then is they spread out throughout his body. Why might they spread throughout his body? If you chose that negatives repel negatives, that's exactly why. That's why the electrons start moving up from his foot through the rest of his body. Now, just like that woman at the gas station, she could have gotten this from her seat cushions, from her pants, right? There's a lot of different ways that this could have happened. And when John comes close contact with the doorknob, which is a conductor where electrons want to move, that static discharge can occur. I'm sure most of you have done this with a sibling or somebody else, where you've taken your socks, or you've gone down to your socks, take your shoes off, and you've scooted your feet across some carpet, and then you shock someone. I'm sure everybody, because it's really dry right now in winter, have shocked somebody at some point, right? This is because a buildup of negative charge gets somehow onto your body, however, through friction, right? And then when you touch something that the electrons want to jump to, we get that static discharge. So we have that example. Another PhET example is our balloon example. So I'm sure everybody at some point in their life has taken a balloon, a rubber balloon, and rubbed it on their shirt or on their head, and then stuck it to a wall. Well, what you're actually doing The rubber is an insulator. It likes to hold on to electrons. And in this case, the sweater here is the conductor. It likes to let those electrons move. So the electrons will move, right, onto the balloon. And now we have more electrons on the balloon, and positives are attracted to negatives. So the balloon wants to stick to the sweater. Now the wall has equal amounts of positives and negatives. So if we put the balloon by the wall, we see that the electrons, all right, because they're repelled, because like charges repel like charges, right, they move a little bit. And electrons can move, protons can't so much. So the electrons move, and that's why the negative electrons are attracted to positive protons. These get repelled, and this sticks to the wall. This is called polarization, and it's different than what we talked about with light and sound. So that is it for today. If you have any questions, please reach out to me or Mr. Oleg, and hope you have a fantastic rest of your day.